How are you, students? My name is Mr. Joha. Welcome back to our lesson in physics, Physics Form 1. And it is in a continuation of the topic of thermal expansion. Today we want to look at biometallic strip. Last time we looked at the force due to expansion, and we realized that there is a force that is developed as a result of expansion and contraction. Our objective today will be to explain expansion and contraction, and also linear expansivity and all the applications that are there. Now, I will start by looking at the biometallic strip. Biometallic strip is one of the applications of thermal expansion in solids. I told you the other day, or in our previous lesson, that thermal expansion can be used in engineering. Your choice of material on how those materials expand and contract will determine how you can use them in engineering. And now today, we want to look at biometallic strip. Biometallic strip can be used in various applications, in various areas where it can be needed. Now, a biometallic strip is when two metals of different linear expansivities are riveted together. They form a biometallic strip. I have one here. This is a biometallic strip. If we have a metal, on one side is iron, the other side is brass. The two are riveted together, joined together, so that they form a biometallic strip. A biometallic simply means bi means two, metallic. So two metals which are riveted together to form one strip of a metal, as this one which we have here shown physically. If we have a biometallic strip as drawn on the diagram there on our screen, the biometallic strip as it is shown, we may have brass, may have iron. So that is a brass iron biometallic strip, the one which is shown on the screen. Even this one, the one I have here, is also a brass iron biometallic strip. Now, when a biometallic strip as shown on our screen is heated, it may bend. Depending on the linear expansivities of those metals, the two metals. The one that has a higher linear expansivity will expand more. Actually, it will expand more. And because of its higher linear expansivity, expanding more, it will make the other one bend inward. So we can see here, brass expands more than iron, and so when it is heated, as in in B, it will bend, making the iron to be in the inner curve, while the brass will be in the outer curve, because it becomes longer, much longer than the iron. So the length of this one will extend from this corner to the other corner, while this one will be a little bit shorter because it is in the inner curve. Now, when you cool that biometallic strip, it also now the two metals also cool. And remember, the metal that has a higher linear expansivity, it means it expands more when it is heated, and it also cools more. It contracts more. It contracts more when it is cold. So in this case, when you cool this biometallic strip, the brass will again contract more, becoming much shorter than even the iron. So it will bend again, having our brass to be in the inner curve, while iron will be in the outer curve. And this is what exactly means. So when you are heating the biometallic strip, brass expands more than iron. The brass thus becomes longer than the iron for the same temperature range. And because of that, the biometallic strip will bend with brass on the outer of the curve, while iron in the inner of the curve. And then on cooling, however, the brass contracts more than the iron, and therefore what happens is that the brass becomes shorter than the iron and ends up being in the inner curve. For example, before we look at an example, I want us to look at this demonstration. I have a demonstration, I have a bimetallic strip, and I want to see how this bimetallic strip is going to behave. I'm going to hit this bimetallic strip for some time. Right now we can see it is actually straight. I want us to hit it. This side is iron, this side is brass. So we want to hit it and see which side it is going to bend. And then from there we will also cool it and see how it is going to cool. So I want to start hitting it. You can see it is starting to bend. And the bending is this side, which has iron, means that the brass on this other side bends more, or it expands more, so it makes the iron to bend in the inner curve. So you can see that it is making such a curve. Actually, that is not straight anymore. It is a curve. You can see that is a curve. So it means that we don't expect it to bend until it bends like it has been broken. No. So this is the way it bends. You can see that this side has made a curve. The outer curve is on the side of the brass. The inner curve is on the side of iron, and that tells us that brass expands more than iron. Brass expands more than iron when it is heated. So this bimetallic strip, the way it is bending, it is giving us an implication that the two metals that we have attached together here have different linear expansivities. Brass has a higher linear expansivity, expanding more than iron, which has a lower linear expansivity. I want us also to cool this, and again we see what will happen when we cool it. I want to cool it. Looks like as I'm cooling it, it's becoming straight. It is becoming straight. It had bent, but now it's now becoming straight. Although this is not ice cold, the water is not ice cold, so it will not bring, it will not make the bimetallic strip to bend on the side of, to bend again. It is actually bringing it to room temperature, the temperature it was before, so it becomes straight. But again, this one is telling us that when you cool it, there is again contraction. The brass contracts more. It contracts more, so it comes back to its normal size. If we put this one in a ice cold water, then the bending will be evident that the brass will again bend to be in the inner curve, while the iron will be bending on the outer curve. So bimetallic strip actually has some applications that we can use because of this particular bending. The bending can be of importance in engineering. And so that is a demonstration that we have. I want us to look at an example of a question. An example of a question. You may be given a question like this one. The figure below shows a set of a bimetallic strip made of two metals A and B. A and B. When it is cooled, it bends as shown. So when it is cooled, that is the way it bends. It has been cooled. It bends that way. So from the diagram, which of the two metals has a higher linear expansivity? Between those two metals A and B, which one has a higher linear expansivity? As a learner, what can you say? And then sketch a diagram of how the bimetallic strip will appear when it is heated. So we are going to look at the answers for that question in our next video. So be around so that you don't miss the answer, because such questions are the questions that may come in your exams. So be around. Thank you very much.